In our previous journey, we traveled to the edge of the ultimate abyss. We watched as massive stars collapsed, tearing holes in the fabric of reality to create black holes. We learned that the event horizon is a boundary of no return, a place where gravity is so absolute that not even light, traveling at 300,000 kilometers per second, can escape its grip. For decades, the consensus in astrophysics was grim but simple. A black hole is a cosmic dead end. It is a locked vault. Matter falls in. It is crushed into an infinitely dense singularity, and it never comes back out. But the universe, as written in the mathematics of Albert Einstein, is rarely that simple. The equations of general relativity, which predicted the existence of black holes long before we ever observed one, contain a hidden, symmetrical beauty. Where the math allows for a point of absolute, inescapable gravity, it also allows for its exact mathematical opposite. If there is a door that only lets things in, could there be a door that only lets things out? And more importantly, could these two doors be connected? Today, we are traveling beyond the singularity to explore the most fascinating theoretical structures in the cosmos. The Einstein-Rosen Bridge. Cosmic wormholes. To understand how a portal through space could exist, we have to stop thinking of space as an empty, static box. Space is a physical fabric. It can be stretched, it can be twisted, and it can be violently warped by the presence of massive objects. In the year 1935, Albert Einstein and his colleague Nathan Rosen were studying the extreme gravitational warping caused by black holes. They discovered something astonishing in the math. When a black hole curves space-time to infinity, it does not necessarily create a dead end. Instead, the intense gravity creates a deep, funnel-like depression in the cosmic fabric. But the math suggested that the bottom of this funnel doesn't just stop. It connects to another funnel, expanding outward into an entirely different region of space-time. This connection is called an Einstein-Rosen Bridge, universally known today as a wormhole. Imagine taking a flat piece of paper. This paper represents the universe. Draw a dot on one end of the paper and another dot on the far opposite end. If you want to travel between these 2 points, you have to cross the entire length of the paper. But what if you fold the paper in half, bringing the 2 dots perfectly together? If you pierce a hole straight through the folded paper, you create a shortcut. You have instantly bypassed billions of light-years of empty space. This is the fundamental architecture of a wormhole. It is a shortcut through the higher dimensions of reality. Space-time geometry. The shortcut. But a wormhole is not just a simple tube. It has specific anatomy. It consists of 2 mouths, connected by a narrow passage called the throat. We already know what the entrance mouth looks like. It is a black hole. Its gravity pulls you in, dragging you past the event horizon and down into the throat. But what happens when you reach the other side? You cannot exit through another black hole because black holes do not let anything out. Therefore, the exit mouth must be a theoretical object known as a white hole. A white hole is the exact time-reversed reflection of a black hole. While a black hole has an event horizon that you cannot escape, a white hole has an event horizon that you cannot enter. It is an object of infinite repulsion. It violently spews matter, light, and radiation out into the universe, but no force in existence can push anything inside of it. If you were to successfully navigate the throat of a wormhole, you would be forcefully ejected out of a white hole into a completely different part of the universe, or perhaps an entirely different universe altogether. So, why haven't we packed our bags and started traveling through the galaxy? If the math allows for wormholes, why aren't we using them to explore the Andromeda Galaxy, located 2.5 million light-years away? The problem lies in the violent nature of gravity. The stability problem, gravitational collapse. Einstein and Rosen quickly realized that their mathematical bridge was fatally flawed. The moment a wormhole forms, the immense gravity of the black hole entrance and the white hole exit violently pull on the throat. The throat is intensely unstable. If you were to attempt to send a spaceship, or even a single photon of light, into an Einstein-Rosen bridge, the absolute mass of the connection would cause the throat to pinch off and collapse inward at the speed of light. The bridge would snap before you even cross the threshold, crushing your ship into a singularity. For a long time, this was where the story ended. Wormholes were mathematically possible, but physically unnavigable. They were death traps. But in the year 1988, a theoretical physicist named Kip Thorne asked a revolutionary question. What if we could build a scaffold? What if we could hold the throat of the wormhole open, just long enough for a ship to safely pass through? To keep a wormhole from collapsing under its own crushing gravity, you need a force that pushes outward. You need anti-gravity. In physics, to create anti-gravity, you need a substance that possesses a profoundly unnatural property. You need exotic matter. Exotic matter. Negative energy density. Every piece of matter we have ever observed in the universe, stars, planets, black holes, and the human body, has a positive mass. Positive mass creates positive gravity, which pulls things together. But to prop open a wormhole, you need a substance with negative mass. If you had a bowling ball made of negative mass and you pushed it away from you, it would mathematically accelerate toward you. If you dropped it, it would fall upward into the sky. Exotic matter with negative energy density would generate a repulsive gravitational field. If you lined the throat of a wormhole with this exotic matter, its repulsive force would violently push against the collapsing walls of spacetime, keeping the tunnel stable, wide, and safe for passage. A traversable wormhole. Does exotic matter actually exist? It sounds like pure magic. But quantum mechanics suggests it might be real. In the microscopic quantum realm, physicists have observed a phenomenon called the Casimir effect, where the empty vacuum of space can actually be manipulated to create a tiny, fleeting region of negative energy. It is an incredibly minuscule amount, but it proves that negative energy is a physical reality, not just a mathematical trick. If a highly advanced Type 3 civilization on the Kardashev scale could harvest enough of this quantum negative energy, they could theoretically engineer a traversable cosmic portal. But if you create a stable, traversable wormhole, you don't just conquer space. You conquer something far more dangerous. You conquer time. The ultimate time machine. According to Albert Einstein, space and time are not separate entities. They are fused together into a single fabric called spacetime. Therefore, a shortcut through space is, by absolute definition, a shortcut through time. Imagine our advanced civilization builds a stable wormhole right next to Earth. The entrance is near our planet, and the exit is located near a supermassive black hole deep in the cosmos. We know from the laws of relativity that extreme gravity slows down time. This is gravitational time dilation. The exit mouth of the wormhole, sitting near the crushing gravity of the supermassive black hole, will experience time much, much slower than the entrance mouth near Earth. If we leave the wormhole in this configuration for a few decades, a temporal desynchronization occurs. The two mouths of the tunnel are no longer existing in the same present. If you were to step into the mouth near Earth in the year 2050 and travel through the throat, you might step out of the exit mouth in the year 2030. You have physically traveled 20 years into the past. Time dilation. Breaking causality. This is where the universe begins to unravel. The possibility of time travel introduces terrifying paradoxes that threaten to break the logical foundation of reality. The most famous of these is the grandfather paradox. If a wormhole allows you to travel into the past, what is stopping you from finding your own grandfather and preventing him from meeting your grandmother? If they never meet, your parent is never born. If your parent is never born, you are never born. But if you were never born, how did you enter the wormhole to change the past? This loop is called a violation of causality. In our universe, the cause must always precede the effect. A glass shatters because you dropped it. You cannot drop the glass because it has already shattered. The causality loop. The grandfather paradox. Many physicists believe that the universe simply will not allow these paradoxes to exist. Stephen Hawking proposed a concept known as the chronology protection conjecture. He argued that the laws of physics fundamentally prevent macro-scale time travel to protect the timeline. Hawking theorized that the moment a wormhole is manipulated to allow time travel, the tunnel acts like a cosmic microphone placed too close to a speaker. Virtual particles of radiation would enter the wormhole, travel back in time, exit, and immediately enter the wormhole again. This creates an infinite feedback loop of radiation, amplifying instantly until the sheer energy violently destroys the wormhole before anyone can use it. The universe, it seems, has a self-destruct mechanism to protect the flow of time. So, where are the wormholes? If they are mathematically possible, why haven't our telescopes captured the blinding light of a white hole or the warped edge of a cosmic tunnel? It is possible that wormholes only exist at the absolute smallest scale of reality. Deep down at the Planck length, a scale trillions of times smaller than an atom, space is not smooth. It is a chaotic, boiling ocean called the quantum foam. In this violent microscopic storm, tiny wormholes are constantly popping into existence, connecting different points in space for a trillionth of a second before vanishing. Perhaps the only way to travel the stars is to find one of these primordial, microscopic wormholes and somehow inflate it to the size of a planet using unimaginable amounts of negative energy. Until we master the quantum realm, the immense distances of the cosmos will remain our greatest barrier. But the math tells us the portals are there. Hidden in the deep math of gravity, the universe has left the door unlocked. We just have to figure out how to open it. Thank you for exploring the edge of reality with me. If you want to keep unraveling the deepest mysteries of the cosmos, hit the like button and make sure to subscribe to the channel. We are exploring the entire universe, one theory at a time. And as always, keep looking up